Welcome to Pre-Calculus. Today we will investigate graphing trigonometric functions. We'll graph three total functions. We want to start off by graphing sine of theta. So in our instructions, we were told that we want to sketch the graph using radians. So as I look at my x-axis, I see that I've got fractions that involve pi. So that tells me my x-axis is already scaled for radians. And we want to use a domain from -2 pi to 2 pi. So it looks like our graph actually does extend to -2 pi. It's not marked, but I'll go ahead and mark -2 pi and 2 pi. And our increments are pi over 4 radians. So we want to do that. And then in the end, we want to identify what's the amplitude and what's the period of our function. Well, let's focus on the graphing first. So what I want to do initially is I want to set up a table for sine of theta. Now I can go ahead and write my domain here. So it's going to be theta values. And it's going to start from -2 pi. And it's going to climb by increments of pi over 4. So I need to mark these. So -2 pi, my next increment of pi over 4 is -11 pi over 4. And then I'm going to pick up my next measurement. It's actually printed here on the x-axis, -3 pi over 2. And then I've got one that is not marked. So that's going to be -5 pi over 4. And then I've got -pi. And then one again that's not marked, that's -3 pi over 4. And then I've got -pi over 2, -pi over 4, and 0. So those are my negative versions from -2 pi to 0. And then we're going to pick up and we want to create the same table values, but with the positive version. So now that I got them written, it's a little easier to record. It's pi over 4, pi over 2. And in fact, what we'll do is let's create an addition to our table. Actually, I see that I'm going to run out of room over there. So instead of that, I'm just going to cut off our instructions. There we go. Okay, so we're good now. So pi over 2. So I'm just kind of mirroring what I did with the negative values. 3 pi over 4. And then I've got pi. 5 pi over 4. And then I've got 3 pi over 2. And I see that I've actually got an error here. So let me fix that error. I called that -11 pi over 4. That should be 7 pi over 4. So I'll make the correction there, -7 pi over 4. So that gives me this mirrored version, 7 pi over 4, and then 2 pi. So there's our full list. It's a lot of x values or theta values, but we got the list there. Now to get our outputs or our y values, what we want to do initially is just take a look at our unit circle. So I'm going to bring the unit circle here. We'd created it on a previous lesson. And the reason I bring that is because for sine and cosine, we have values that are really just marked on the unit circle. So the ones that are in yellow, the x values of those coordinates are our cosine values. The green ones, the y values, are in fact our sine values. So what we can do is use what we've got on the unit circle to come up with our outputs. So where I'm going to start is 0, because the unit circle is predominantly positive in the way that it's labeled. And I'm just going to pick up the y values. So I see here at 0, the y value is 0. And then I'm going to just keep going around the unit circle. So at pi over 4, we're not taking all these measurements. Pi over 4, it's square root of 2 over 2. So I do need to calculate that. So square root of 2 divided by 2. Let me make sure to include parentheses. Square root of 2 divided by 2 should have the value of, I put the parentheses in the wrong spot. So that has a value of 0.71. So we do want to convert them over to decimal values to graph here on our plane. Pi over 2, so I'm just going to keep wrapping around unit circle. Pi over 2 has a value of 1. So I'm just looking at those green y values. 3 pi over 4 is also square root of 2 over 2. So we already calculated that. That's 0.71. Pi has the value of 0. 5 pi over 4 is negative square root of 2 over 2. That's negative 0.71. And you can start to see a pattern now. 3 pi over 2, that's this lower 90, has a value of negative 1. So now I'm going to start to predict. I believe the next should be negative 0.71, and then 2 pi should be 0. And I can use this same pattern once I've caught the pattern just to create my negative values. So as I go to negative pi over 4, that should be negative 0.71, negative 1. And then it rises again, negative 0.71. At negative pi, I have the value of 0. Negative 5 pi over 4 is 0.71. Negative 3 pi over 2 is 1. Negative 7 pi over 4 is 0.71. Negative 2 pi back to 0. So as you can see, the values for sine, they are really irrational, but then again, they repeat over and over and over. So let's graph this one so we can see what the curve looks like. So negative 2 pi is 0. And then at negative 3 pi over 2, I see that I don't have everything marked here. So in fact, negative 2 pi is one further to the left. So I'll mark that and kind of transfer that measurement over. So negative 2 pi is going to be there. Okay, so we're set now. So at negative 7 pi over 4, it's at 0.71. So I just estimate that value. And then at 1, and then down at 0.71, 0, negative 0.71, negative 1, negative 0.71, 0, 0.71, 1, 0.71, 0, negative 0.71, negative 1, negative 0.71, 0. And what we get when we connect these points with a continuous curve is essentially a wave that just continually oscillates from 0 to 1 to 0 to negative 1 and so forth forever. So that's our first function. That is sine. Our second example, and let me pause here. We want to do one last thing. We want to identify amplitude and period of the function. So let's identify how we can find, first of all, amplitude. So to define amplitude, it is the distance from the x-axis to the maximum value of the crest of a wave. So for us, the amplitude here, it's going to be the maximum y value. And that's going to be an amplitude of 1, because you see that sine oscillates from negative 1 to 0 to 1. So the absolute value of the maximums is going to be 1. The last thing we want to mark is period. And period is essentially what's the interval on the x-axis for the function to complete a full cycle. So I see, like, looking at what we've got here, we have 2 complete cycles. So it would start here at 0, rise to 1, back to 0, to negative 1 to 0, and then it repeats. And so for us, our period is the the distance on the x-axis for the function to complete a full cycle, typically we take the positive direction. So this sine function is from 0 to 2 pi, and then it's going to start repeating the same y values. So again, amplitude is the height of the wave. Period is the breadth or width of the wave for it to complete a full cycle. Now we could graph cosine from the yellow values, and it would look similar, but just shifted. But what I want to work on just now is the tangent function. So I'm going to jump down here to tangent, and let's go ahead and create our same table. So what I want to do again is just populate our table just as we did on the previous function using increments of pi over 4. So I'll put theta and y. And let's go ahead and mark our values here. So just like we did on the previous example, I want to start off by marking. So my graph doesn't go fully to -2 pi. So for this one, where I'm going to start is just -pi. In fact, I could probably bump back one more to -5 pi over 4. So that's how we'll treat this tangent, just kind of responding to our x-axis on our graph. So then we'll start counting up. So -pi, -3 pi over 4, -pi over 2, -pi over 4, and 0. And then we'll just repeat that, but mirrored in the positive. So pi over 4, pi over 2, 3 pi over 4, pi, and then make sure I get a pi in that negative version, 5 pi over 4. So that's what I've got here on my graph. So again, we want to take a look, if we can, at the unit circle to see, can I come up with tangent values? So there's our unit circle again. So we'd already said that the yellow values, the x coordinates from unit circle, would give me cosine. The green ones, the y coordinates, would be outputs for sine. So for us to find tangent, the traditional way is to take the green and divide it by the yellow, which is how we define tangent. Tangent is opposite over adjacent. So on the unit circle, opposite is going to be the vertical component, the y, divided by the horizontal, which is our adjacent. So we'll pick up a couple of these, and then we need to see if we can identify a pattern. So I'm going to start at 0. 0 is a good place always to start. And the reason is because that is standard position on my unit circle. So I'm going to start at 0. Look in there. What I've got essentially is a y value of 0 and an x value of 1. So for tangent at 0, it's going to be 0 divided by 1, which is just 0. Okay, we'll go to pi over 4. So pi over 4, I see that my x and y values are the same. They're both square root of 2 over 2. So if I divide the green by the yellow, it's going to be square root of 2 over 2 divided by square root of 2 over 2, and that has a value of 1. So then at pi over 2, I've got the coordinate 0, 1, so the division there is going to be 1 divided by 0, and that's undefined. So we'll see how that shows up on the graph of tangent in a minute. So then let's pick up again. So 3 pi over 4 is over here in the second quadrant. There my numbers are the same, square root of 2 over 2, but the x value is negative. So it'd be square root of 2 over 2 divided by negative square root of 2 over 2. That's going to be -1. At pi itself, we're back to -1, 0. So that's going to be 0 divided by -1 is 0. And then 5 pi over 4, they're both negative, but again, the same value. So negative square root of 2 over 2 divided by negative square root of 2 over 2, that has the value of 1. So I'm starting to see a pattern that I can use. Basically, I go from undefined to -1, 0, 1 to undefined. So if I just back up, negative pi over 4 is -1. negative pi over 2 is undefined. And then negative 3 pi over 4 is 1, 0, negative 1. So you can quickly fill in your table once you identify the pattern, which essentially is noticing the period of the function. So we'll graph this one. I'm going to start here at negative 5 pi over 4. That's negative 1. Negative pi is 0. Negative 3 pi over 4 is positive 1. And the undefined value at negative pi over 2 is going to represent a vertical asymptote. We'll then pick up the pattern again. So now I'm at negative pi over 4 is negative 1, 0, 0. Pi over 4 is 1. Pi over 2, undefined. And then the pattern again. So 3 pi over 4 is going to be negative 1. Pi is 1. 5 pi over 4, positive 1. Now, if I'm to graph this function, it kind of has a repeated pattern going on. The closest function that looks like tangent is going to be the cubic function. So essentially, it's repeated what look to be one arm down, one arm up curves separated by vertical asymptotes. So you start sketching them, they all have the same arrangement, separated by vertical asymptotes. So tangent's a very different graph from sine or cosine because it's got this separation by vertical asymptotes. And if I were to expand that, that would continue forever. So last thing for us to do with tangent is to identify the amplitude and the period. So amplitude for tangent is going to be, in a way, infinite. And you can think amplitude is what's the distance from the x-axis to the top of the wave. There is no top of these waves. They go forever. So you can look at the idea of amplitude two different ways. You could say that it's infinity. Another way of saying that is that it's not defined. However, when we come to period, we can really easily define period. And really, it's the horizontal distance from asymptote to asymptote. So my period is going to be from negative pi over 2 to pi over 2. Well, that's a full distance of pi. So the period for tangent, it's about half the period of sine or cosine. It's going to just be pi. Sine and cosine at a period of 2 pi. Well, let's take a look at our final example. So we looked at sine, we looked at sine and tangent. Now we want to say, how do I graph one of these reciprocal functions? So here I've got y equals secant of theta. So I'm going to start the same way. Our instructions are just repeated there. So what I'll do is create the table. And we'll put, again, theta is our domain. And then we'll have our output y. So it looks like our increments here are the same as our tangent graph. So I'm just kind of responding to the graph the way that the x-axis is labeled. So I'll put negative 7 pi over 4. That's that leftmost point here. That's negative 7 pi over 4. The negative 3 pi over 2. Negative 5 pi over 4. So it's the same increments of pi over 4 that we were using at first. Negative pi, negative 3 pi over 4, negative pi over 2, negative pi over 4, 0. And then we want to put the mirrored positive direction. So pi over 4, pi over 2, 3 pi over 4, pi. And almost got all of it. 3 pi over 4. I'm sorry, 3 pi over 2, and then 7 pi over 4. So that's the full domain. Lots of values here. But again, you mark them all, and then you're looking for some patterns. So we need to think about how we would have calculated secant. And I'm going to again bring the unit circle, but unlike sine, cosine, and tangent, really I got to do some additional manipulation to catch secant. So we just need to remember the way we define secant. Secant is given as the reciprocal of cosine. So cosine is adjacent over hypotenuse. So secant is hypotenuse divided by the adjacent side. So essentially for secant, what we're going to do is take the hypotenuse, which for the unit circle is always 1, and divide it by the yellow x value. So we'll start again at 0. 0 is always a good place to begin because that's standard position on the unit circle. So it's going to be 1, the hypotenuse length, divided by the x value of 1. So that value is just 1. At pi over 4, it's going to be 1 divided by the square root of 2 over 2. Again, I'm just picking up the yellow value there. That we got to do some manipulation. So I'm going to multiply that by its reciprocal. 2 square root of 2, it'll cancel. 2 square root of 2 is just going to give me 2 over the square root of 2. Got to rationalize that denominator. So that's going to be 2 times the square root of 2 over the square over 2, I'm sorry. So it just boils down to square root of 2. Well, that has about the value of 1.414. So we calculate these, and then what we'll do is we'll notice the pattern so we don't have to keep calculating each time. But let's get to where we've got a full period of output values. So at pi over 2, I've got an x value of 0, so this is going to be 1 divided by 0. So like our tangent function, I'm seeing an undefined spot in secant. Okay, so we'll pick up at 3 pi over 4. So that's the negative quadrant 245. So that's 1 divided by negative square root of 2 over 2. Well, we already calculated the positive version. That's square root of 2. So this is going to be negative square root of 2, which has the value of about negative 1.414. At pi, the value is negative 1. So it's going to be 1 divided by negative 1. And that's going to be negative 1. 3 pi over 2 is, I think I've missed one here. I got 5 pi over 4. Let me make sure I catch that value. So we'll just adjust here. One of the challenges with finding, okay, I got 3 pi over 4. I'm good. One of the challenges with trig functions is just keeping track of your domain. We're used to having domain values that are just by ones. And here it's all fractions and it all involves pi. But we'll catch it. So 5 pi over 4, that's right here. So that's again going to be 1 divided by negative square root of 2 over 2. And that is going to be, again, negative square root of 2, which has the value of negative 1.414. And I think we're onto a pattern here, because as I go to 3 pi over 2, I see that we're back to x value of 0. So that's going to be 1 divided by 0 for my output, which is back to undefined. So now I see a pattern, and it's really kind of a doubled pattern. It's a lot like sine, where I've got positive values and then the same numbers but negative. So if I track backwards, I'm going to go from pi over 2 undefined, pi over 4, 1.41401. Negative pi over 4 should be 1.414. Negative pi over 2 undefined. And then the negative pattern should pick up negative 1.414, negative 1, negative 1.414, and then at negative 3 pi over 2 undefined, and then the positive version, 1.414. So a very regular pattern with all these trig functions. We're ready to graph. So I'm going to pick up here. We just found this value at negative 7 pi over 4. That's going to have the value of 1.414. Negative 3 pi over 2 is undefined, so that is a vertical asymptote. And then we're picking up with the negative version. So negative 5 pi over 4 is negative 1.414. Negative pi is negative 1. Negative 3 pi over 4, negative 1.414, undefined. And then repeating the pattern on the positive side. So it's 1.4141, 1.414, undefined. Now on the negative side, negative 1.414, negative 1, negative 1.414, undefined. And at this point, I'm not even looking at my table. I'm just working off the pattern that I see in the graphing. So I've got the points plotted, and we're going to see something similar to tangent, to where this function is shapes curves that are separated by vertical asymptotes. But unlike tangent, they're going to alternate. Some are going to be above the x-axis, and then the next one is going to be below. So go from above, below, above. And the closest thing probably that we have to these individual secant curves would be something like the parabola. But even different from the parabola here, these do not extend to the left and the right. They're restricted by these vertical asymptotes. And so for secant, what we see is this kind of repeated up, down, like tangent, separated by vertical asymptotes. Our last thing to note here is how to treat the amplitude and the period of secant. So the amplitude, like we saw for tangent, remember amplitude is the height of the wave. Here, my curves are, again, infinite in the y direction. So I could either say that the amplitude is infinite or not defined. When I try to characterize the period, however, that's very defined. And what I want to catch is what's the full interval on the x-axis for me to complete one cycle. Now, one cycle here involves one of the curves that's below the x-axis and one that's above. So I'm tracking from negative 3 pi over 2 to pi over 2. Well, that full distance is 2 pi. So it's bigger than the period of tangent, and that's because tangent, they're all the same curve, whereas secant, they're the same curves but reflected, one above, one below, so forth. Thank you for joining for this investigation of graphing the basic trigonometric functions. See you soon.